Chapter 1 of Spacehounds of IPC by E. Doc Smith. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, visit LibriVox.org. Spacehounds of IPC. Chapter 1. The IPV Arcturus sets out for Mars. A narrow football of steel, the interplanetary vessel Arcturus stood upright in her berth in the dock like an egg in its cup. 100 feet across and 170 feet deep was that gigantic bowl, its walls supported by the structural steel and concrete of the dock and lined with hard-packed bumper layers of hemp and fiber. High into the air extended the upper half of the ship of space, a sullen gray expanse of 50-inch hardened steel armor, curving smoothly upward to a needle prow. Countless hundred of fine vertical scratches marred every inch of her surface, and here and there the stubborn metal was grooved and scored to a depth of inches, each scratch and score the record of an attempt of some wandering cosmic body to argue the right-of-way with the stupendous mass of that man-made cruiser of the void. A burly young man made his way through the throng about the entrance, nodded unconcernedly to the gatekeeper, and joined the stream of passengers flowing through the triple doors of the double airlock and down a corridor to the center of the vessel. However, instead of entering one of the elevators which were whisking the passengers up to their staterooms in the upper half of the enormous football, he in some way caused an opening to appear in an apparently blank steel wall and stepped through it into the control room. "Hi, Breck," the burly one called, as he strode up to the instrument desk of the chief pilot and tossed his bag carelessly into a corner. "Behold your computer in the flesh. What's all this howl and fuss about poor computation?" "Hello, Steve." The chief pilot smiled as he shook hands cordially. "Glad to see you again, but don't try to kid the old man. I'm simple enough to believe almost anything, but some things just aren't being done. We have been yelling and yelling hard for trained computers ever since they started writing us about every 1 centimeter change in acceleration, but I know that you're no more than IP computer than I am a Digger Indian. They don't shoot sparrows with coast defense guns." "Thanks for the compliment, Breck, but I'm your computer for this trip anyway. Newton, the good old egg, knows what you fellows are up against, and is going to do something about it, if he has to lick all the rest of the directors to do it. He knew that I was loose for a couple of weeks, and asked me to come along this trip to see what I could see. I'm to check the observatory data. They don't know I'm aboard. Take the peaks and valleys off your acceleration curve, if possible, and report to Newton just what I find out, and what I think should be done about it. How early am I?" While the newcomer was talking, he had stripped the covers from a precise scale model of the solar system and from a large and complicated calculating machine, and had set to work without a wasted motion or instant, scaling off upon the model the positions of the various check stations and setting up long and involved integrals and equations upon the calculator. The older man studied the broad back of the younger, bent over his computations, and a tender, almost fatherly smile came over his careworn face as he replied. "Early? You? Just like you always were, plus 15 seconds on the deadline. The final dope is due right now." He plugged the automatic recorder and speaker into a circuit marked Observatory, waited until a tiny light above the plug flashed green, and spoke. "IPV Arcturus, Breckenridge, Chief Pilot, trip number 4329, ready for final supplementary route and flight data. Tell us to Mars." "Meteoric swarms still too numerous for safe travel along the scheduled route," came promptly from the speaker. "You must stay further away from the plane of the ecliptic. The ether will be clear for you along route E2, P6, W41, K3, R19, S7, M14. You will hold a constant acceleration of 981.27 centimeters between initial and final check stations. Your takeoff will be practically unobstructed, but you will have to use the utmost caution in landing upon Mars, because in order to avoid a weightless detour and a loss of 31 minutes, you must pass very close to both the Martian satellites. To do so safely, you must pass the last meteorological station, M14, on scheduled time plus or minus 5 seconds, at scheduled velocity plus or minus 10 meters, with exactly the given negative acceleration of 981.27 centimeters, and exactly upon the pilot ray M14 will have set for you. All X. Breckenridge studied his triplex chronometer intently, then unplugged and glanced around the control room, in various parts of which half a dozen assistants were loafing at their stations. "Control and power check-out. Hype," he barked. "Driving converters and projectors." The first assistant scanned his meters narrowly as he swung a multi-point switch in a flashing arc. "Converter efficiency 100, projector reactivity 100, on each of numbers 1 to 45 inclusive. All X." Dirigible projectors. 2 more gleaming switches leaped from point to point. Converter efficiency 100, projector reactivity 100, dirigibility 100 on each of numbers 1 to 32 inclusive, of upper band, and numbers 1 to 32 inclusive of lower band. All X. Gyroscopes. 35,000. Drivers in equilibrium at 10 degrees plus. All X. Upper lights and lookout plates. The second assistant was galvanized into activity, and upon a screen before him there appeared a view as though he were looking directly upward from the prow of the great vessel. The air above them was full of aircraft of all shapes and sizes, and occasionally the image of one of that flying horde flared into violet splendor upon the screen as it was caught in the mighty roving beam of one of the 12 ultralight projectors under test. "Upper lights and lookout plates, all X," the second assistant reported, and other assistants came to attention as the checkout went on. "Lower lights and lookout plates." "All X," was the report, after each of the 12 ultralights of the stern had swung around in its supporting brackets, illuminating every recess of the dark depths of the bottom well of the berth and throwing the picture upon the screen in lurid violet relief. "Lateral and vertical detectors." "Laterals XP2710, all X. Verticals AJ4290, all X." "Receptors." 15,270 kilofrancs, all X. "Accumulators." 700,000 kilofranc hours, all X. Having thus checked and tested every function of his department, Breckenridge plugged into Captain, and when the green light went on, "Chief Pilot, check out, all X," he reported briefly. "All X," acknowledged the speaker, and the chief pilot unplugged. 15 minutes remained, during which time one department head after another would report to the captain of the liner that everything in his charge was ready for the stupendous flight. "All X, Steve?" Breckenridge turned to the computer. "How do you check acceleration and power with the observatory?" "Not so good, old bean." The younger man frowned in thought. "They figure like astronomers, not navigators. They've made no allowances for anything, not even the reversal. And I figure 4,000s for that, and for minor detours. Then there's check station errors." "Check station errors? Why, they're always right. That's what they're for." "Don't fool yourself. They've got troubles of their own, the same as anybody else. In fact, from a study of the charts of the last few weeks, I'm pretty sure that E2 is at least 4,000 kilometers this side of where he thinks he is, that W41 is 10 or 12,000 beyond his station, and that they've both got a lateral displacement that's simply fierce. I'm going to check up and argue with them about it as we pass. Then there's another thing. They figure to only 2 places, and we've got to have the third place almost solid if we expect to get a smooth curve. 1/100th of a centimeter of acceleration means a lot on a long trip when they're holding us as close as they are doing now. We'll ride this trip on 981.286 centimeters. With our scheduled mass, that means 36 points of 47 kilofrancs plus equilibrium.